Hey, I'm gonna walk through how this Burnham Hydronics boiler works. Spent a lot of time figuring this out this weekend with the people from All Steamed Up, who are really great in Baltimore, and Gordo was super helpful to me. But I wanted to go ahead and sort of like document and save this in case maybe me or somebody else needs this information from the internet. Okay, so. This isn't going to be like the most pro video or anything because there's a lot of tight spaces, but just bear with me. All right, so the way this thing works is it has at least 3 really cool safety systems that prevent basically your house from filling with CO2, which obviously you don't want, so good thing. But I'll just kind of walk you through the way that this kind of works. Maybe there's a 4th one too. All right, so right here, this is electricity, 110 volts coming in. This is the gas coming in, and then this is the thermostat control. So when the thermostat calls for heat, it sends a signal along that line. All those go into this little this box here, power, thermostat. Well, I guess 2 of them, the electrical ones. The gas goes to the bottom here. The gas goes down here, and then along the bottom into this gas control valve, which is a lot like the one on it looks a lot to me like the one on a hot water heater or water heater. This one doesn't have it's an auto igniting pilot, so it doesn't have any of that stuff. This is just a simple on off, so it's a little different than the one on my water heater. Over in the electrical space, you can see this like very common step down 24 VAC transformer. So I have one of those on my like doorbell, and like there are a lot of places in the house. But so it goes from like 110 down to 24 volts. 24 volts VAC is nice because if you touch it, you get a little zap, you can feel it, but it's not gonna actually hurt you. So this is a steam boiler, so it has water. And so this is the safety system to make sure that there's water in it. And so this light can either be green or red, depending on how much water is in the system. And then there's also this sight glass where you can see it. There's a valve that lets you empty the sight glass right there. And we have this little bucket that's always waiting here for us, so if we want to check that in there. There's also this pressure sensor here for this Honeywell thing. This panel comes off with a single screw, and there's like if it's over pressure, it will cut off the power, and you can see it's like this wire here is like a power cutoff. So the basic thing, the way this works is this is the power that's going into, well, there's a couple different ways to cut off the power to the ignition system. And once you do that, then the whole thing will lock out until the safety things are restored. So I didn't totally debug this overpressure sensor, but I think that that's probably the same thing. Like it's like, this is, I think, a high voltage one, or it could be low voltage, it's hard to tell. But there's this little thing in between here, so I kind of can't tell. So yeah, it's probably, maybe it's 24 volts too. So maybe the 24 volt power, I would guess, probably goes into here. And then if this is overpressure, it will like cut the switch off, and then you won't get 24 volts any further. But then eventually 24 volts comes down this line, and this is this red and white is 24 volts. And this is the control unit for the whole boiler, this black one. So 24 volts goes into these 2 24 volt ground, 24 volt here. That's the power in. And the power out, PV is pilot valve, MV is main valve, and then this PV/MV, that's the common. So this is the 24 volt out of this box to those other places, and this is like where the intelligence of this unit lies, in this black box. So power in, power out, and then there's also ground. So this black line goes through 2 other sensors, and one of those was at fault when we were working. So I'm going to kind of document that now. All right, so the way this thing works is this red line is bringing power in, and then it goes to this sensor down here. This sensor has something to do with basically like it's like gas or like some kind of heat sensor, saying that like down here where all the burner tubes are, gas comes in and they get ignited. If something's going wrong with the combustion here, that sensor, it's like sort of like kind of looks like a resistor or a capacitor. That thing will trip, and then it will stop voltage from flowing from the red line to the black line, and that will mean that there's no power to the ignition system. You can see here that this is sort of subdivided before it gets to the ignition system, and it goes out this line here. This line goes around the back. So let me walk you over there. Okay, we're back at it. Okay, so this wire here is that line, and this is the flue, right? So this damper motor, this is what went bad originally and caused the whole problem. So I'll get into that next, but I'm just going to finish the train of thought that I was talking about with that other sensor. So down here, this is called the flue spillover sensor, and what it is it has two. Let me see if I can get it here. It has two leads. Man, oh, this would be really hard for me to show you. I should have done it before I was turned off. Let's see. You're looking at me. Oh wait, actually, you can kind of see it. All right, cool. So you see those two leads, and then the middle, there's actually like a little switch. It's kind of brown, and what happens is, if hot gas fails to go out of this, this like exhaust, this sensor will heat up, and the connection between those two leads will break, and that will mean that the connection to the power to the igniter system is off. Will kill that. This is a detent, so once it gets flipped, it will stay flipped until somebody manually resets it. And this was the issue for me, is that this switch needed to be manually reset. Now I wasn't able to actually, well, I couldn't figure out how to reset this until I unscrewed it, and then it was extremely obvious. But now that I have been in there once, I can show you how to do it. Basically between these two, let me see if I can show you. Between these two little wing things, there's a detent switch, and you can push it. It was really easy for me to do once I unscrewed this, and I was able to do it really easily. To confirm this was the case, I just took those little blade connectors off and just put like a pin between them so that they would connect. And then I was like, oh, this is what it is. This is the problem. All right, so the last thing I'll show you is this damper motor control. So this opens and closes this like bar here. Let me show you. This bar, this is a damper. What happens is when the system is off, the damper closes to keep keep cold air from coming into your house. But then when the system powers on, there is a damper motor will open, and inside of there's actually like 3 little micro switches. And I kind of think what happened is the motor just burned out. The micro switches act the same way as like a safety lockout. So if the damper is not in the right position, it will like cut off power to the 24-volt igniter system, and that is a safety feature. So what I originally did is I sort of jury-rigged this damper motor, and it worked for a little while, but then I think eventually what happened is it wasn't as fully open as it could be, so it caused that flue overflow thing to reset or to break the connection. So that was probably good. So it probably meant that the damper, even though what I basically did is I unscrewed this damper motor and I kind of like just put this into position, but I didn't really like put a clamp on it or anything. So maybe it was like sort of occluding itself a little bit, and that could have caused some problems for me. I have a CO2 and a gas sensor right next door here plugged in, so it wasn't enough to like cause that sensor to fire. I have like a separate just like thing I bought on Amazon, like a plug-in one. So it wasn't that much, but something was a little bit hotter than it needed to be. So let me show you a little bit about what I learned about the damper motor. All right, so what are we looking at here? So this is just like a little motor, and it runs on 24-volt AC. And it's 1 revolution per minute. So it moves really slow, which is great. It has this little, this is the insert for the wing of the damper motor. The like little, the bar that actually opens the damper. And it has this little stepped cam on it. And you can see there's like 3 different positions. And those correspond to those 3 micro switches. And you can hear them clicking. This is just like a totally analog circuit here. There's a relay. There's this little switch that basically puts it into manual versus automatic mode. And there's just like a single capacitor, single resistor, single diode. Maybe there's 2 diodes. And so the power comes into here, and it's the same thing. It operates as just like, there's a call for heat signal, and then there's like a cutoff. And if this isn't in the right, since this is like mechanically coupled together, these switches are reading out the position of this dial, and if it's like not in the right position, it will cut off power to the ignition system. So what I originally did is I just sort of like overrode this by just like mushing this around. Eventually kind of stopped being able to do that, so then I just took the whole thing off and I manually put the damper in place. But then of course the signal to this, like it didn't think it was in the right position. So I'd sort of like jury that for a little while, knowing that that was just a temporary fix, and I ordered another one of these. But then, like I said, what happened is this overflow sensor, it started to trip, and then I had to go debug this all. So yeah, so I kind of think those are the main systems of this boiler. I'll just kind of go over here again. It's a pretty awesome thing when it works. So let's see, I've got, my system has like a full on there. I guess what I can do is, let me have it like call for heat, I guess. All right, so I called for heat, and actually, let me put it all back. All right, so right now the damper end is in kind of an unknown position. You can kind of see that bar. It's like vertical right now. I think it's basically part way through the whole thing. So let me turn this back on. I've got the thermostat in the call for heat system. So what happens is this thing powers on. This is like the autofill. And then you're going to see this damper thing go into position, I think. Yeah, you can see. Okay, you hear it? So it's twisting all the way shut now. So now it's horizontal. So it kind of resets itself to a known position. And then since it's a call to heat signal, it should, oh yeah, here we go. So now you can hear it opening up. You can see the little thing spinning. And then once that gets into position, that will enable power to go into the pilot system. So like now that's totally vertical again. And now you hear the little thing, and then you hear the pilot clicking, and you're gonna hear, yep, you can hear the fire, and you can maybe even see, I don't know if you can see it, but there's fire happening now. And so yeah, so this sensor down here and that other sensor, they would have cut off power if it wasn't right. And then like the way this thing works is there's like, this is the autofill system. So this like loop is for the autofill, and then that's like a manual fill, and then that's just like a maintenance valve. So if you want to like, this box it has like a valve in here basically. And when the level gets too low, it will like fill it, and then you get this little counter. Tells you how many times it's kind of operated. But that's all connected to this like sight glass stuff over here. So all right, I kind of think that's it. The big thick pipes are how the water goes to the actual radiators. And then maybe I'll just finish by just sort of like wrapping it up, looking at this panel. But yeah, this is a really amazing system, right? Smart people over a long time designed this very safe, very cool, very like analog system. So very impressive.